Let's create an equivalent quadratic expression by completing the square. Problem number 3. X squared minus 10x plus 9. Step 1. Find the missing part by dividing the coefficient of x by 2, then squaring it. So we are going to start with the coefficient of x, which is negative 10, and we are going to divide it by 2, and then take that quantity and square it. Negative 10 divided by 2 equals negative 5, and we still need to square it. Negative 5 times negative 5 equals a positive 25. The missing part that we need to complete the square is positive 25. How did we find the missing part? To find the missing part, we took the coefficient of x, negative 10, divided it by 2, got negative 5, and then squared negative 5 to get positive 25. Step 2. Add the missing part after the x term and subtract it at the end of the expression. X squared minus 10x plus 25 plus 9 minus 25. Because 25 minus 25 equals 0, this is still an equivalent expression to our original expression. How did we add and subtract the missing part? To include the missing part 25 that will allow us to complete the square, we added 25 but also subtracted 25 to keep the expression equivalent to our original. Step 3. Write the expression in the form of a square binomial with a numeric term. To create the square binomial, we have to factor these first three terms into identical factors, so we know it will be x plus or minus some number squared. If these are identical, then we know that they must have a 5, because 5 times 5 equals 25. And to combine to a negative 10, they both need to be negative. Negative 5 and negative 5 combine to a negative 10, and negative 5 and negative 5 multiply to a positive 25. So x minus 5 squared. Then we just combine the numeric terms. 9 and negative 25 combine to a negative 16. And we now have an equivalent expression in the form of a square binomial with the numeric term. How did we write the expression? To write this final expression, we factor the first three terms into a square binomial, and then we just combine the final numeric terms. You are now ready to create an equivalent quadratic expression by completing the square on problem number 4.